Hello everyone. Welcome to Remote Sensing and GIS for Rural Development NPTEL course. This is week 4, lecture 2. In this week's lecture, we have been looking at using QGIS and introducing GIS concepts so that we can analyze the remote sensing data. I hope all of you have downloaded the QGIS software, which was shown in the last week and last class. So today we will install it just to show that how the installation process goes on and to make sure that you don't get stuck in the way of installation. So let's go ahead with the installation. I'm going to share my folder. So in your folder, you would have seen this part where you have installation, right? You have double-click this part where you could go for the installation, which I downloaded in the previous time. And you will come across the installation window like this. I hope it's visible. I'll just make it visible again for those. I'll have to stop share and share. So now you will be able to see the installation web page, and I am going to showcase the installation now. So in the installation, you will be seeing this part, right? So now you could see that the installation process has started. It does take a little bit time, and you can click the bottom screen. So you just say next. In the next window, you will have overview of the license, the raster plugin, which is a type of data. We will cover it today. And then MRS, ID, raster plugins from GDAL, zip, Oracle Instant Client, etc., etc. So you just go through all the license agreement. We cannot read it in the class time, but I recommend you to fully read it. I've read it, and so I'll accept the terms. It's a long page, so make sure you read it. It's a generic statement. It's 4 years, 5 years old. So then you go next, and then pick a folder in the C drive where you want the software to be installed. Normally, automatically it picks the C drive. C drive is more stable. Do not put it on your desktop. Do not put it on your other drives where if any error comes, it'll just get lost. Okay, so C drive is now normally used for installation. Create a desktop shortcut if you want, and create a start menu shortcut. I click both, but if you don't want, you can unclick. And then click next. Click install to begin. Okay, so it will start running, but before that, in the bottom of the screen, you can see the pointer. It will be asking, can you change the software? Is the software allowed to change the setting on your system? You should say accept, because it is going to put software on your desktop or laptop, you will have to accept it. Okay, so in the meantime, while it's installing, I think we should be able to see slowly the status improving. It takes time, and also I'm recording the lecture, so it will take time, but let it go through. In the meantime, we will look at the types of spatial data. So this is a very important topic that we need to cover for the lecture. GIS data is of two types. So you download the data from remote sensing and you collect data from observation data. There are two types of data. So this is kind of the basics of GIS. I will not get fully into the basics, but just some part of the basics we will cover. Okay, so of the two types, the first type is raster, which is very important for this course. It is a remote sensing and GIS. So most of remote sensing, if not all, are raster data. So the data that you're going to use in GIS for spatial data is two types. One is raster, one is vector. And the first one, raster, is also a continuous data wherein throughout the map, throughout the canvas, you will have data, not in only some pockets. So that is important to understand because you will be looking at the status. I'll just check the status now and then. Okay, so here now it is asking me, my software is asking me, should I allow the software to run? I say yes. Once I say yes, it starts computing, validating, and installing. So let it install in the background while we discuss the course topic of the data. Okay. I'll keep it here so that you can also see how it runs. So as I said, there are two types of data. The raster data is more continuous. Examples are air photographs taken from reconnaissance survey, planes that take data from the ground up, and also scanned maps, topographic maps, any image which has fully covered with data. For example, if you have a sheet of paper, okay, so you have all this data in it, right? All the colors. And so which means the data is full. All of the pixel, every pixel is covered with data. So like that, you will need to look at data as across the canvas or only in some points. If it is across the canvas, it is called raster data. Most remote sensing data is raster data. Okay, the vector data is of discrete types. Okay, vector is discrete features, a layer comprised of individual points, either points, lines, or polygons. Example, statues are points, it's a point on each location. Roads are lines, and state boundaries are polygons. We will cover each of this separately in this week's lecture. This week, we will look at vector in particular in the remaining lectures. Raster will come next week. I will devote 1 week of lectures for raster because raster is more important for remote sensing data. You could see here, as I mentioned, most data is, remote sensing data is raster data. Whereas your vector data is discrete features. You can convert between these two data formats, but it is advised that some features are lost. So to keep these two separate and only change if it is needed. So let's look at this data concept in GIS in particular. We have spatial data where is the location. Okay, so spatial and attribute data is important in GIS. Where is the data taken from is called the spatial data. It gives you the specific location of the data. In GIS, each data has a data and information, which is attributes, but also the location where the data is collected. And that is what makes GIS different from other softwares. So we should be able to capture that part very, very carefully, because we have space location data inbuilt in GIS data. So it is stored in the shapefile, geodatabase, or similar geographic file, whereas attribute data is descriptive data about what, how much, and when. So this is the actual data. Let's say census data. So census data is population data. It is data about how many people live, how many males, females, let's say. If I'm just giving data itself, it is attributes. You have males, females, total population, attributes. But we are also having a location attached to it. Let's say Tamil Nadu's population. So Tamil Nadu is the spatial location, which is the first bullet. Then the second bullet is what data comes into the system. So these are specific characteristics at that location, natural or human created. These are stored in database table, in a table format. Okay. So we have both spatial location now and table data associated with that location in GIS. So in GIS, normally they are maintained separately. Okay, in a GIS environment, you will see them, the data being managed separately, right? It's still copying the files. So I'll just check if we have done with the files. It's still going on. Let it go on. And what we'll do is so we have GIS systems separately, traditionally storing them in different files, but now, and they join them and display for analysis. So when I talk about the structure of data, you will see that one GIS file will have 7 to 8 associated files. And in one of the associated files, the location of the data is stored, whereas the data as table is stored in another file. When you open this file, this shapefile in GIS software, it combines this and projects the data as one data. Okay, so that is what the last bullet means. And then we have representing data with raster and vector models. So we have here different models of data, right? So we have data that represents both raster and vector. We will see in a real life scenario how it is done. Okay, raster model, it is area covered by grids. As I said, if you have the map throughout, let me draw it for you. Yeah, so you have a map, and in the map or the map area, every single area is having the data. This is in raster format. So how is this accomplished? It is divided into pixels of equal size. So these are grids. Okay, so I'm not doing straight, but in a normal situation, each data is going to be gridded. I'll show you an example, but I'm just showing you how, and each point, each grid will have data in it. Okay, so that is why it is called continuous, equal sized, and square cells. Let me clear this page. Okay. And so what happens is you have equal size cells. Attributes are recorded at each single cell where the value is going to be placed. And you will have a majority of the features in the cell. For example, land use. If in a pixel, you have 70% as forest, 30% as urban, the pixel will be colored green, which represents forest. Yes, 30% is urban, but because the pixel can take only one color, one value, it will take the majority color. Image data is a special case of raster in which the attribute is a reflectance value from the geomagnetic spectrum. Again, as I said, a satellite or a plane is taking an image, remote sensing object is taking an image of the planet, of the land, and it is, when it takes an image, it's the reflectance, how much light is reflected and in what colors. So when the reflectance happens, the reflectance is monitored and captured in the camera and converted into digital image. In the digital image, coloring is based on how many colors the camera can capture. So cells in image data, often called pixels, called picture elements. In a vector model, the fundamental concept of vector GIS is that all geographic features in the real world can be represented either as points or date or dots, nodes, trees, poles, fire plugs, airports, cities, like they are as points. Okay, so imagine we have, I'll just check if the software has been updated. It's still running, so let it run. Okay, you can see it here. Yes. So what we will do is we will have more points or dots representing trees, poles, figures in the vector model. In the meantime, I have noted that the software has downloaded successfully. Let us quickly look at the software, for which I will open. So now if you could see my other screen, I'll just open the other screen so that you could see. So if you could see the screen, this is where we downloaded the software. And if you click your start button on the top, you could see that your GIS has been set up. Basically, your GIS 3.22.14 and what location it has come has been there. So I'm going to open the 3.2214, which is the long stable version. And then your 3.28 is your newest version with multiple features. The feature rich one is there. Remember that you should remove your previous ones. I have my older version also, but that's the beauty of QGIS. It lets you run multiple versions, because some people like the older version. They have the older version and the newer version also in the same system. So once you click your QGIS, this thing opens up, which says that welcome to the long-term release. The version is given and the name. Each model is given a name, Biotovizia, or I don't know how to pronounce the last dot, is that A. So these names are taken and given by QGIS, and it starts. So always you open a new product, and then it says some plugin has crashed. You can just ignore the warning, but now your QGIS has been set up. So in the next course lectures, I think week 5, 6, we will have hands-on on how to use this. So I'll use this video for that, but I just wanted to show you how to install it into your system and then take it up. So let's get back to the lecture notes that we were presenting. Okay. Yes. So we stopped here where we said points or dots, nodes, trees, fire plugs, airports, and cities, where you have a vector model. A location is taken for these as a point, and for the point, data is being stored. The data can be anything, but examples are trees, poles, fire plugs, airports, and cities. And that is one type of vector data. The other type of vector data is lines, where you have a combination of points joined together as a line, and the location of the line is also split in different points. We will not see that part, but we will definitely see the line in your image and a perfectly placed line in the geolocation. It's not like randomly placed line. It has a location and it will be placed likewise. Okay. And then we have areas. So a combination of lines become polylines, and then polylines become polygons if they are connected and closed. So areas are polygons where it is again starting with points, it converts to lines, lines convert to polygons. And polygon examples are land parcels, cities, counties, forest, rock type. So these boundaries can also be put on a GIS map and with the location and with the data. So the last part we would like to see here is, my video has gone up. Let me bring it down. The last part we would like to see here is, because representation depends on shape, GIS refers to files containing vector data as shape files. Since it has a shape, point is a shape, line is a shape, and a polygon is a shape, we call this as point files. Let's look at a real world so that you can understand how the system works. In a real world of concept, the top part is a real world where you have a river flowing. So the line here is a river, and then you have houses, forest trees, and then houses on both sides of the river. Okay, so now I'm going to convert it into the two types of data we have in GIS: raster representation and vector representation. Let's do the raster first because we have discussed that. As I said, the image is first discretized into grids, equal size square grids. The size depends on the spatial resolution of the camera. So here you could see that it has been divided into grids. Each grid gets a unique number. This is 0, 0, 1, 1, 1, 2, 1, 3, 1, 4, etc. So we don't care about the labeling scheme, but for now, rows, columns are given, 9 rows, 9 columns, and then the grids are being established. So each grid is of equal size, and inside the grid, there is only one value for data. You cannot have houses and rivers in the same box. It's either house, river, or a blank, or a tree. So there's only 4 data types. There is blank, this is land, or let's say land, and then there's a house, there is a tree, or a river. Only 4 types of data that can be represented in this image. So here in the raster representation, you see the blank, which represents the land. You see the H, which is the house, and then the river going as connected grid as R, and then you have T for trees. You could see that it is not like 3 trees are here, 4 grids are colored. No, it's the space. The space occupied by 3 trees is represented by 4 grids here, and then 1 there, and then a house. So all these are on the location of where the data is being collected. So this is the raster representation of the real world, wherein we have the real world painted as a whole canvas in the raster, but in the vector, only the location where exactly the house is. Here also there is a location, but the whole grid is colored as house, whereas here the location, exact location, only a point is kept for houses. The trees are combined as a forest, as a polygon. So all this area is taken as a polygon, and then the river is created as a line. So here you see the river going through as a line, and the data points, line and polygon has been covered. So this is very important for understanding the conceptualization of a real world into raster and vector. And then we move on to one more example. In the next example, I will also show you how the 3D effects are going to be captured or not captured in a raster. So here, going from bottom up, we have the real world. You could see that the real world has some imperfections and undulating surface. It's not a flat surface, but GIS is about converting this onto a 2D frame. Your computer screen is a 2D frame. So you're going to put this image on a 2D map, and then each data point can be converted for the 3D image. So in a real world, you have a landmass, some water body, a lake, and then streams that get into the lake, a forest, and a marshy land. So this is the real world. Imagine that you are having a real world where you have different types of attributes or data. In a vector world, how it looks like is you are converting that into a 2D surface first, and not all parts of the surface needs data, but still the data is represented as grassland, which is the brown, and then this part is the marshy land where some green is there, so light green is given. Forest comes on the top north part of your study area, so that part is a polygon also, and forest is being mapped, and then the streams are lines that drain into the another water body polygon, which is the lake. So you have the lake, the forest, and the grassland, the marshland as a polygon, and then you have lines also in this vector representation. You do not have points, but that is also okay, because point can be used for marshes or forests, but it's not necessary that all vector data should be represented in your image. It can be purely in a map, it can be purely points, it can be purely lines or polygons, or a mixture or combination of either. You don't have to have specific all of them in or a partners and stuff. Any number of data as per needed can be used. Now come to the raster world. In the raster world, it is not as straightforward. You will have to convert the entire 2D canvas into grids, and each grid has to have a data. There is no part in the grid which says no data. So you could see that all of them are colored brown, and on top of it, there is marshland which is colored yellowish green, and then you have the blue, which is the river and the water bodies, and then you have dark green for forest. The green color is looking at the forest, which is being reflected back as green. So what do you see here very carefully is the grid size dominates for these kind of analysis for raster, because the thickness of the river can be small, maybe small, but if the grid size is big, the entire grid is going to be colored as blue. So you could see here that the majority is blue, so all of the grids are showing blue, but this line might be smaller. This line might be smaller than the top line, and that cannot be differentiated in a raster, because the raster will still think that majority of my grid is blue, so I'll color it blue. So this is the only issue, and it is not as clean. So you could see that the grid is just connected one grid to the lake. So it is not as natural as a river flows. So it doesn't flow as blocks, correct? So in raster, you will see that the data flows as blocks, whereas in a vector, it is smooth as lines and stuff. However, it is not continuous as raster. So that is where there are benefits of using either data set. So one data set is not better than the other data type. It depends on your use, how you're going to use the data, and what you're going to use the data for. So moving on, the differences here we see are the raster data has cells and pixels. The grids, as I said, is called cells or pixel, or you can interchangeably use them across your understanding. Grids is equal to cells and pixels, and each of them have a property that across the grid, across the canvas, across the image, the grid size is the same, and it is a square grid. You cannot have rectangle on the top and then square on the bottom. Also, the square should be of same size. The size again is divided and estimated by the cameras and the data acquisition system. So we will not get into that, but understand that whenever you download a raster data, you should understand what is the grid size, which is a spatial resolution, and the grid camera or whatever has been used to form the grids. In the next part, which is vector, you have features. So data is divided as cells, pixels, grids in the raster, whereas data is divided as features in the vector type. So here you could see marsh, lake, forest. Those are names, but those are also features under which data are stored as attributes. So you have marsh. So in the marsh, you can have type of marsh, size of marsh, length, breadth. All these things can be added as data. The major item is your feature, and within the feature, you have attributes. So it's like your column name could be your feature class, whereas your rows in a table could be your attributes. The grassland is a type of feature. The lake is a type of feature. The entire table can be called as land use, land cover classification, and that is being used to represent the real world scenario. Again, the real world is very complex, but you're trying your best to capture it in a raster or a vector format. Please understand that because there's a lot of grids and more representation, continuous data, raster is always bigger in size. It consumes more memory storage compared to vector. Vector, you can show a lake as a point, a line, or a polygon. Only part of the map area is going to be used. Whereas for raster, even though a small lake is used, the entire image has to be classified. You cannot just classify the lake grid area. You will have to classify the entire area. So these are the pros and cons of using the data types. There are two data types in GIS, raster and vector. And raster is where a continuous data set is created by discretizing the image, forming grids, whereas in vector, the important features that are needed to be mapped are identified. They are converted to point, line, or polygon, and then they are input into the system. With this, I will stop today's lecture. I will see you in the next lecture where we will specifically look into the vector data set and how it can be used for rural development. Whereas in the next week, we'll look at the raster data set and how it is used for rural development. Again, those who would like to learn more on these type of data sets and GIS, please take the recommended NPTEL courses and or any courses that talk about GIS data types. It is the same. It is not different because different people teach it. It's a very basic, simple entity. We do not teach it here because then the load on GIS will be more rather than rural development. The understanding is you will learn this or you had already learned GIS data types before you came here, but it's fine if you don't. Please learn it in the site. We'll be using that in the rural development concepts. Thank you.